Hello student, today we are going to start lab lecture 4, mainly focused to the machine learning. We already start many lab lectures, data visualization and data analyzing, which is beginning of the big data analyzing, and then now we are going to dive to more specific functionality and some hands-on exercise related machine learning. We will see and we will enjoy a lot of tools, especially very practical and interactive tools to learn what the meaning of the machine learning. You remember that the learning, when we start from the data pyramid, start from data and information and then knowledge, insight and wisdom and optimization. And we explained that old algorithm compared to the new AI algorithm, new one can learn based on the data-driven approach and more implicit than old and traditional algorithm, which is explicit. So the direction showing the learning part, and after problem solving, knowledge and representation, we come to the learning part. So today we are going to less explanation, more practical part. Sometime for practical part we need to know some concept. So I try to do trade-off between some practical hands-on exercise and any theoretical related that practical part. So in the this course is the AI and big data, and this is Professor Abolkasem Sadeghi Yaraki, and we are in the lab lecture section. So let's again recap some point based on what we discussed before. Machine learning is a method that lets the computer learn from data. So is the data driven. There is three main important parts for machine learning. One is the supervised learning, the other was unsupervised learning, and last one is the reinforcement learning. Let's show you the figure we discussed before. You may remember at the beginning we focused about the problem solving. Later on, AI approach 2, you can see this is one, related knowledge and reasoning and planning. And third one is related to the learning. And the fourth one is the communication, more advanced one. And you may remember also we explained in the data and approach move from here to here. And learning, especially this part, using the insight and wisdom of the human and learn. If we look at AI approach learning part, one of the important learning approach is the machine learning, and the other is the supervised learning and reinforcement learning. In the supervised learning, there is many classes like decision tree, logistic regression, linear regression, SVM. You see this sort of name. And unsupervised learning is a clustering, k-means, PCA. Maybe you may ask one question: how AI using the new AI, right? New algorithm-based AI, because old one used the problem solving, but the new one used based on the learning. I'm going to ask very challenging question. And if some of you pass some online machine learning or AI, even CS student, they already technically know some coding. Maybe some student, they know KNN, or some of them, they know deep learning. But conceptually, you may don't know what is the really concept behind, AI and machine learning. Whole AI, machine learning, deep learning, everything in this figure, as I explained before. So please pause the video and think about and answer me as a class activity how I can categorize this sort of algorithm, through which concept. If you tell me one short explanation of this algorithm, what you can see, what you can explain. After I explain some of them and do some practical, depend on the time of class, practicing, taking many classes, but this is you just follow already existed teaching material, but you don't know what is the philosophy behind that. As you saw during this semester, I deeply and logically and conceptually taught AI and big data. So for this part, I invite you to think about, can you summarize all these algorithms in a unique and specific way, simple way, what they are looking for, how these algorithms. So today I'm going to first talk about this answer to this question. Generally, I explain all of this, algorithm, then go inside, explain what can we do and how practically we can do something. So please pause the video and think about that one. So before answer that question, again, I need to remind you that the AI is the big zone. Machine learning, what we are going to touch, which is part of AI. So once I am talking about the, for instance, decision tree, so this is the AI. Although it's a machine learning, but we are going to artificially grab human intelligence. So that's why this is part of that. And later on, when we talk about the deep learning, for instance, neural network, this is part of machine learning and part of AI. So you should pay attention to this point. So machine learning that enable that AI system adapt to the new situation, new context, and with trying to implicitly program, as here said, implicitly, without being explicitly means implicitly. So this is the point. And the learning is machine learning, deep learning, reinforcement learning. This is the branch of AI. But in the machine learning, try to learn from data to identify the pattern and make a decision with less interaction with the human. In the deep learning is one branch of the machine learning, right? Use the neural network, biological concept, like deep neural network with a multiple layer, some of them hidden. So to try to use the large data set. So difference between machine learning and deep learning use more data than machine learning and takes very complication than machine learning. It takes long time to learn from the data. Machine learning is less. So machine learning divided supervised, unsupervised learning and reinforcement learning. So in the supervised learning done based on the label data. So we know what the data are. For instance, some data means some photo and image of animals. We know this animal is dog, so we have a 10 photo, 5 is dog, 5 is cats. We know. And then we try to learn from those image, and then when we give the new image, can recognize. We try to learn machine and then ask something. For instance, when you join to the company, At the beginning, they may send you some training program, even support you, some classes. But after you train and improve your programming language, they will ask you to work with them, work for them, implement some project. So this process in the human life we do in the supervised learning and unsupervised learning, they do same. But in the unsupervised learning, we don't have the information about the data. We have just data. We have some point. We don't know what they are. We have some image, but what we don't know what the image are. For instance, we know some images from some two different city. It looks like some photo from city A, some photo from city 2, but we don't know city name. Then somebody bring us some photo from those city. After we train them through city 1, as for example 100 picture from city 1, 100 picture from city 2, we give and train them. Then somebody give another data which is not part of this data, new data from city 1 or 2, show to the system. System will tell this is the city 1. Cannot say city name because it's the unsupervised. But here we know the data. For example, like Seoul city and Tehran city, we have a data. We give here in supervised. And then we give one photo from Seoul or Tehran city. Then machine recognize this is Tehran. We label one. This is no label. Reinforcement learning through the try and error and receiving some rewards. And try to learn and learn. Not because here one time we learn, we train and finish. Here one time train them and we make a model and then we request. But reinforcement learning is circulating. Learning some error again, spend some time to learn and continue. So you may remember for deep learning also we discussed that artificial ANN, this is the inspired from biological neural network and multiple layers for complex pattern. So many type of neural network is like CNN, RNN, and more generative adversarial network is again. So more advanced one is the transformer. This is like ChatGPT is like transformer. So this is the deep learning. So what is the difference between machine learning and deep learning? As I mentioned to you, difference is the architecture, data, feature, computational power, and application. So in the architecture, typically use the algorithm like decision tree, SVM, something like that. But here using the neural network is more complex. Data, machine learning, you don't need many data, but here is a mini data. Machine learning, require the human, interaction, human access for feature selection and extraction. But deep learning doesn't need the human. Extract the feature from the raw data, totally is the data driven. Computational power, with a small computer and limited CPU, you can manage machine learning. But for deep learning, you need more advanced and more big, and especially you need the GPU. And application like, for instance, machine learning, spam detection, fraud detection, but for deep learning, speech recognition is very specific, autonomous driving or language translation. So this is what the difference between those. So I am going to, machine learning supervise little bit, very technically talk about this. This is the answer of question which I ask you. I spent many days to prepare even this single table. You may say, oh, this is a table, but after many years working in the AI and smart environment, and think and thought. So I made this table. Please respect, and you may, not able to find such an explanation any places. This is, very wonderful table, and let you simply, whole learning, including machine learning and deep learning, machine learning, including supervised learning, unsupervised learning, will be covered here. And it's very okay. When we look at this table, let's focus about the supervised learning and unsupervised learning and reinforcement learning. These three is part of machine learning, right? And please pay attention. After working with many algorithms and do many projects, implement many algorithms, you come to the point. For instance, like decision tree learning, random forest, KNN, K nearest neighborhood, naive Bayes, SVM. This is part of supervised learning, as well as, there is many algorithms. This is the famous one, linear regression and logistic regression, which is part of our classes. So today I want to teach every machine learning algorithm through this table. So even later on, no explanation about that. Through this table, I already covered it. So I spent too much time to make it this table, because especially some of the students, they don't have a CS background. So I feel this is very necessary to let them easily understand very complicated algorithm. So I'm explaining very, straightforward and very simple. These algorithm, decision tree, we will touch some practical activity to some of them if we have time. So all of them is a classification, is some sort of classifying. That means you try to classify data. They give you some data. Based on this approach, you try to classify. For instance, data is like that. So you want to, and there is another data like that. In the supervised, remember, in the supervised means the data's name. So you want to classify data, understand data in detail, cat and dog. And then when you understand the model, and let me very simply explain. This is the machine, this is the human. If I show this human one photo of cat, if I ask this human what this photo is about, human said this is the cat. But when I ask from the machine what this photo is about, machine cannot understand. So through supervised learning, I try to mimic intelligence techniques, methods, how the human learn, transfer to the computer. How? Here, using classification technique. Means first, I try to give some photo of the, cat or dog. Through the DT, means decision tree, I will make a hierarchical. For instance, the characteristic of the cat is like that, dog, many other characteristics, categorizing, teaching, and through this sort of random forest, similar decision tree, more advanced one, more trees you will consider. Nearest neighborhood means the nearest one, and we will talk later about the difference between this, but simply I could say in the decision tree, classify item which we know based on the name, based on the characteristic. But in the random forest, classify based on many, this is many tree, right? This is trees. Here, same decision tree, random forest. Because, tree in the forest, there is many tree, right? In the forest, many tree. So this technique, not only one characteristic and labels, many labels as a tree. So this is the random forest. So in the nearest neighborhood means the data which is similar together identified. Similar item like image recognition. This is like random forest is like spam detection. This is for fraud detection. Spam is more complicated than fraud. But in the naive base, here, use finding the classification and classify each item to learn to the machine using the, probabilities. Same thing, but probability, when we add probability, Bayesian network is looks like using this technique for image classification. SVM also is a classifying. So try to find, optimum boundary between each classes. What is the optimum boundary? But here, just roughly classify. But here, make a more optimum way. For very detailed, for example, cancer detection. All is a classification. So all of these is the pre-categorized data. So let's go for regression. For the regression, we have a linear and logistic. In the classify, we try to make a detailed one. For example, one object like cat, find many detail. And then all detail collected together go to the one. All detail of the dog go to one. Means unify. Unify first, find the detail, classes, then manage classes to unify. This is all algorithm detect. For example, they try to teach the machine. When you see the one image, try to separate it and detail section here. And then make unify to make a decision what is that. So make a different class to understand. So classification means you make one big object, we will teach to the machine big object, go to different classes and then unify. In the regression, I will add more slides and explain later on. Regression also means return to the original one. Return to the mean regression. Because here we return. We first classify in the tree. We make a like many branch. Here we have a many branch here. Many things, find many detail. And then we try to move from here to here and also from here to from here, return to the original one. But first detail means dispersion, classify, and then return. Here regression, same, but sometimes linear, predict the value from the trend. Here data is a continuous, but this is non-continuous data. So that's why we are using this one, the difference between these sort of algorithm. Logistic regression, predict based on probability, but here just trend. This is like market forecasting. Here is like credit scoring, but here we use the probability like SVM. But all is this is continuous data like trend. But here is not continuous data, but this is trend. Is data is continuous. So this is looks at classification. So all of these supervised classification is we will use prediction. We try to predict when the computer try make it detail and find the classes combine to predict. So mostly this supervised classification, all of this main objective is the prediction and using predictive model. You remember when we were talking about the many levels of you remember when we draw like this figure, it was descriptive analytic, and then talk about the diagnostic, and then predictive, and then prescriptive. So this is, and here is a descriptive, diagnostic, predictive, because here the learning part, and then prescriptive. So remember, many times I'm repeating and connecting many concepts together. Wonderful. Wow. So now let's dive into this part. Maybe here is, but I will, in the next page, also I put bigger one. You can see, but I don't want to delete this one. Maybe, yeah, let's delete it. No problem. Go to the next page. We already explained this one. Talk about the supervised. So in the supervised learning, but I prefer this image because I can see whole. I think it's clear. You can see here. Let me, if font is not clear, I think it's clear. It's a clustering, association, and dimensionally reduction. This is the unsupervised. So many algorithms which I'm going to cover here. So let's go here again. Here was a classification, type of continuous classification, which we call it regression, but meaning same, Latin word. Clustering mean we try to cluster. Classify, regression, cluster, association, dimension reduction, all of them means we find a small piece and then we collect it to the unique one to teach to the computer like this. I'm very professionally I am explaining this algorithm. You cannot find such explanation. Please respect this lecture. And respection is not saying, okay, well done, professor. No, respection means many times watch this video. I spent too much time to make a very simple table. You easily now understood. If you know SVM, easily you will understand that is supervised learning. Mostly use probability is some sort of classifier. Even you don't know what is that. Then practically we will touch. But even you don't know, you will understand the real meaning. I am sure some of you already did many projects, for example, for PCA. But you don't know really the meaning. Okay. Here is a task driven. You defined this is the cat, this is the dog. But here you don't talk. Unsupervised, it doesn't mean you hide the label. You don't know because you already collect some data, you receive some data, but you don't know what the data meaning. This is the point. Then you use this algorithm. You want to teach to the computer. How to teach? All is the same. All is many. Find the detail and then grouping to understand. This is the all machine learning. Try to learn. But here, when you want to teach something to the computer, but those data you don't know, you use this one. So clustering. K-mean clustering or K-mean, sometimes called no-need telling clustering, and you may see K-mean. K-mean, please don't confuse K-mean with KNN. K-mean with KNN with KNN is a supervised, but this is unsupervised. Hierarchy clustering, this is similar trees, but here you know the label, but here you don't know. So since they don't know, they can put decision trees, unsupervised decision trees, same. So K-mean group similar items like customer segmentation. For example, you have a many dot. I will teach you some interactive environment to learn what really this means. You want a cluster. Cluster means, let me read. I want to find what the green one. So this is one cluster. So this is the easy one. So what if we have some green data here? Then how do you classify? Then you need to reclassify. You need to bring here a cluster, bring like this to add. So this is the clustering, using this just similar. But here you will hierarchy data, organize data in the nested cluster. Is it the normal cluster? But this is complicated cluster. Here, like trees, one trees, but this is many trees. Here same, but because this is for unsupervised data, like for document clustering. And association rules, find the frequent item set, like market basket analyze, same. This is same clustering. Association means a small thing you unite it. Now some sort of unsupervised is like clustering, but before doing clustering, decrease the dimension. Means decrease, you have a many data. Here you don't have big data. Here use for big data. You have a big data, it is very complex to visualize. So you reduce first complexity, then visualize. Representation learning. So in the representation learning, first you discover new data to make clear, and then extract data. Again, both of these means detail grouping is like clustering, but for some big data. So all of supervised learning, you try to structure recognition, pattern recognition, because pattern and structure is unknown, but here known. You know this is cat or dog, but here is unknown. So that's why is very useful approach to try go for pattern. So this is for pattern recognition, but this is just prediction. You try to predict. You try to learn something, predict for unknown data. Give you known data, which you know, to predict unknown data. But here, you give unknown data to reach to known data by some pattern recognition. In the reinforcement learning, as you can see, here is based on the data. Here based on the decision. whether you reach to the specific decision or not. This is decision making through the reward. But this is inside of this similar clustering. Again, here in the reinforcement learning, you find the detailed one grouping, go here back, but here no back, but here back. So we need to optimize action to receive the best situation, like autonomous driving. So here is the prediction. This is pattern recognition, but this is for, adaptive learning. You need to adapt your situation. This is same, but if you want to read, you can pause the video, same. Then let's go for deep learning. In the deep learning, is both data-driven and task-driven. So in the deep learning, including all section of the machine learning. So category there is based on the cluster. This is based on neural, biological concept. So the basic deep learning is the artificial neural network, convolutional neural network. Most, image computer vision identify object in the image, like autonomous vehicle, through the image recognize some object, whether this is human, obstacle, anything, based on the very detailed data and many data. This is a recognized pattern in the complex data, somehow related unsupervised learning, like image and speech recognition. Recursive neural network is a sequential prediction, like supervised learning, but defined very sequential, like language translation. You need to recognize character, recognize the word, grammar, and then to the sentences, and then come to the meaning and semantic. RNN. Generative adversarial network is a generate the realistic images, like deepfake, these days using the GAN. Transformer models getting very popular, natural language understanding, like chatbot. All of this is the high level feature extraction and prediction. Again, this is same. You detect a small thing of the object, autonomous, but more data, grouping, all is grouping, detailed grouping. All of AI means like that. Learning is meaning like that, simply. Wow, wonderful. I really enjoy myself the way of teaching. Many algorithms within few minutes I explain. So let's little bit more and then touch some hands-on exercise. So this is very point. For this slide is my several years experience. It's not easy word. I didn't copy paste from every other lectures. I made it through my experience. From multiplicity to unity. Wow. All AI is here, especially machine learning and deep learning part. Supervised, unsupervised is through this slide. And you can understand many things just based on this simple metaphor. And understand, as a path of learning in the machine learning and human development. Why human development? Because we are going to, get some learning from the human to the machine. So this is very important. So So this is the main concept, and then one by one I will let you what happened, whether multiplicity to the unity is happen for every algorithm. Yes. So machine learning try to reduce complexity, moving from multiplicity to unity. You cannot find such a definition anywhere. This is my definition. By collecting, grouping, clustering, classification, everything into the unified structure, they help discover meaningful pattern. Similarity, effective human learning require collaboration and unity. This is very similar to human. With grouping, you can do many things. So one of the advantages for many countries, East Asian countries like Korea, is this point. They use the AI-based grouping, collaborating, unify. These days, when I tell to the foreign student work together, many times after 1 week, 2 weeks come to me, oh, we cannot work, he or she is not available. Professor, can I work by myself? I can work more. Group is a headache. No. Bring the diverse person together and share. This is the answer to those students is, hey, all algorithm is try to be find every person characteristic, then united. All of algorithm doing this. Why you are going to work individually? So this is the point. If you see the algorithm I already talked, moving from multiplicity to unity. In the several algorithms you may remember, like this decision tree, random forest, KNN, naive Bayes, SVM, all is classification. Remember, regression, linear regression, clustering, KN. So here, all classification grouping into, different classes to simplify complexity, come to the one classes, one group, like decision tree, random forest. Regression, identify, modeling relation within data to predict the outcome, means you come to the unique. So linear of the market, moving from multiplicity to the unified understanding of trends. Here, unsupervised learning, from diversity to the unity, grouping similar data to create unified structure, like K-mean. Clustering for customer segmentation to the specific unique segment. Association, discover relation, pattern between variables to simplify. Dimensionality reduction, remember? Just come here. Where is that? Here. PCA and representation learning. Pattern recovery, unsupervised. This is also reduce the complexity to reveal a simpler unified pattern. Reinforcement learning. You do some decision toward the unity, to be united. Decision making through the reward. Agent interact with its environment, adjusting its behavior based on the reward. The final goal, to come to the unified with a maximum reward. Unified goal with a maximized situation. Okay, I think this is enough. Let's compare classification and clustering from some aspect. Classification, remember, supervised learning. Through today lecture I explain all algorithm. You should, for only machine learning itself is 1 semester. But I try to teach you very professional way in a short time many things. So here, supervised learning means class you know, class you don't know. So that's why they put it classification, cluster. Maybe some of you said cluster and class same meaning, but same meaning since they make international wording, they use some keyword, but all of them is the same meaning. They want to unify it. But here, when we say supervised, supervised classification, unsupervised classification, we have a known data. Using some learning technique, this function is this one. All of this algorithm is a function. So through this one, we come to some known. This is supervised. We have many dogs. We use human knowledge, train. Human knowledge is here. All is the human knowledge. Through the several years, many people suggested many techniques how we extract and learn to multiplicity to united situation. This is the human. Maybe some of you introduce new algorithm. Why not? So we give many data. So in the hands-on exercise we will do. We will give many data and then extract the cat and dog. What does it mean? I give many dog, cat. I give new image to the system. The system said this is cat or this is dog. Another thing, I give many housing information. How many meters, square feet, or pyong, or meters square meter. You give based on that and price. You go to the real estate, collect many information. Then you draw one line and talk with your parent, with your couple. Okay, do you want a house? He or she, your father, mother, your couple, your wife, your sister, your brother, whatever you want to buy together a house. Your couple or yourself decided, okay, how about buy only, for example, 100 meter square. Then based on the information you collected, you will roughly know the price. And then your roommate, your parents said, oh, we have more money. Why don't we buy much more houses? Then, based on the market already collected, you don't know by hand, by one table, two house, 10 house, maybe it is easy. And sometimes your data, for example, there is no any data. For example, you are talking about $2 million, but there is no $2 million. But if you make a model, no data, $2 million, but roughly you can know how many meters square can be selected as it. This is wonderful. You can get some data which you don't have. This is the advantages of the machine learning. I want to give you one important point. Human, without machine learning, can use traditional way, go to the many real estate, collect many information. For little information is okay, but when you have a big data information of whole real estate of the Seoul city or New York City, then it is very difficult one by one check. And if you want to find a house, for example, 200 meter square, but in your data, there is no such a data, then you need to calculate how. It's very confusing. But if you data you collected, bring to the computer and give data and train them. What is the meaning? This is a linear regression. This technique, which I explain, is this technique. Linear regression is a continuous data, many data. It's not dog. It's not between dog and cat, some animal. So it should be here. Is a supervised learning in this algorithm. But here is a trend, the price of a house. every part is a data. But when data is separated, discrete, this is continuous. Here is meaningful, but dog, cat, only here. In the middle, no meaning, but here, house, meters, so that's why it's a linear. Some probabilistic is a regression. So in the regression, it's not like that. It's like this shape. It's because it's based on probabilistic. But here, linear, based on line. So you should remember like this. So when you go here, so this model very helpful if you teach computer. So wonderful. You now understand supervised learning. Unsupervised learning. So the data which you are going to know, you know the data, but you don't know the label. So then you come to some output which you expect, sometimes not expect. For example, using the, as you can see here, like k-mean, means group similar item. You have some animal, but you don't have a name. But here you have a name, no name. But when give to the computer, computer finds similarity of the animal, said animal one, cannot say what is this. Later on you can teach and label to the result, okay, this is the cat. But basically, computer doesn't know. Here, try to categorize, k-mean. But sometimes it's easy. You say, oh, okay, I can do by myself. But sometimes it's not easy. You cannot do. Machine is good. Like this, you know, it's very difficult to find. Many data is mixed, you know, light blue, dark blue, everywhere. So you need this is the raw data. This is the, you know, cluster data. This is when you talk about the cluster terminology, you should remember when we talk about the cluster, here, cluster means unsupervised. You cannot change terminology. Okay, now let's do some you know, interactive tools. Maybe this is consider some break, or if you feel tired, you can pause the video, take a rest, and come back to very nice section. Very wonderful section I'm going to cover now. Okay. Machine learning interactive tools. This section, I spent a lot of time for non-CS students who they don't have much knowledge of computer programming development, but they want to learn about the AI. This section is good for them. Day and night, I'm thinking how make every student happy who is very active in computer science and a very knowledgeable student who doesn't have a knowledge in computer science should enjoy this lecture. Especially these interactive tools, you know, made for non-CS student. But it doesn't mean this is not good for computer science based student. This is good. The way I will teach will be useful for both of them, and you really you know, enjoy. And sometimes I try to record the video, quickly send the material, but sometimes I instead of that I decided to not to do so, to just prepare more valuable data. For every minute of these lectures, I'm thinking how a student can be happy. So this is that part, interactive tools. So very wonderful. And you know, these information you cannot find in the one place. I search, spend time, check it, and test it, whether working, thinking whether the new student with the less knowledge can understand that one, how that would be easy way to teach them. So the result is like that. So the first one is the orange. So it's wonderful, drag and drop environment. So this part now is considered as a hands-on exercise. So this section, we will do some practical, but not through the Google Colab section, using with some web-based or desktop-based software, but it is very wonderful. So I would like to start with the Google Teachable device. So you can type, teachable machine, or type this address. You can come to this section. And I put many things, so we will try to work with those websites. Let's dive into Teachable machine, which is introduced by Google, and very wonderful data can use and train them. So let's go inside. So through this part, you can, through the Teachable machine with google.com, you can read many documents through this one, explain the way how you can use it, but many example, many tutorial, you can work on it. But today we are going to practically do some hands-on exercise, and that will be useful for you as a beginner. Later on, you can extend it by your data. So let's press get start. So here we will touch three sorts of data. You remember in the slide which I mentioned, we are going to do some supervised learning in this hands-on exercise. We give some data and then train the machine, and then when give some specific data, try to help us. So let's start with the first one, image project. So let's do this one first. So in the first one, we will use a standard image. So we defined first one as we will use some water bottle. So we put the bottle model, and this one we will put as a book. So you can upload some existing data already you took, or let's try by webcam. So you can use your webcam. So this is the water bottle. So I want to get the data. So you need to hold this one and then move different parts to get the data. I just hold this one. You need to show different angle. For example, 153. And then another object I'm going to train as a book. So different, more detail you get. So the accuracy will be more, right? And then we train the model. The model start to be trained. So now is a training. So this is a simple way. So now already trained. So if I show the bottle, see, even if I do this, since I already trained, 100% showing this is the bottle, right? And if in my webcam, if I use the book, even if I do, because I already train computer with this direction, this will be very nice. Then you can export your model here for your website or whatever. And you can receive some data. Okay, now we can use based on the some existed file, for instance with a no label or with a label. So with a label is like this, but with a no label you can download from the Google. So from the no label, since my data was a no label, yes, nearly 100%. This is not my real data, right? This is download from the, is it, you know, here, if you see this one, is the door, that door of that one was the white one, but this is the black one. So that's why 99%. But if I download one with a label, so this is a little bit different. And this model is the not professional model. And then for the way I train, you know, this model should be, see, not 100%, confused. So this is the one reason. So, but basically, you understood the main concept of, you know, this is supervised learning. Okay, let's check it out, another one, audio project. For the, you can already, if you have some file, you can train. This is supervised. So for instance, you could say, let's say put some noises. I try to use some chocolate. So let's record it. I just then you can extract, you know, I use the chocolate cover to make that sort of, just this was a noise, I accidentally little bit talk, but anyway, extract it. So 14 audio, you can extract more, like nearly 40. Another one, let's make another sound hitting the pen to the table like this. Let's say pen sound, and so this can be, so here 39, but less is better because training maybe takes more time. So let's train. Pen, is it the chocolate cover? Pen. Great, good job. Let's try the pause project. For the pause project, you can go to the Kaggle. So Kaggle is a data set. It's a free data set. You know, you can access too many data. So through the Kaggle, please type this one. You will reach to the data, which I already found this data. This is the pause. Actually, here, when you do this, you can open your webcam and shows your body and based on your body skeleton. But I'm going to try for uploading for the this one based on the uploaded data. So you go to the Google Pose, then you will see test data and train data. For instance, test data has a plank like this shape, or you go to the here tree shape. This is the like this is tree, no, this is the plank, so go for tree one. So this is the tree shape. Okay, but I download it, so I have here. So from train data, I will take it, train the model. You know, I divided my data two parts. So this data is two parts. Usually, when you have many data, right? This is the generally the concept. You need to divide your data two parts. One as a trained your model. So this is the train data. Another data as a test data. So as a test. So this is the train, this is the test. Because you should test your data. And remember, data of this data totally different from the train data. See here, train data, for example, plank. This is the data, right? But when you go to the test data, plank, they are different data, not same data, from different person. So this is the plank. So usually in the machine learning, we need some data to train the model. To make sure, we need to use another data, whether model working like bottle, which I use based on the webcam. But when I try to test it, I use a web-based. So here, same. So you can press download, test and train. This is very good example. And free access is a Kaggle. Of course, you need to log in based on your email, and then you can have many access. This is very useful website for dataset. You can have many availability code, so you can have a code access using this dataset and some discussion, or depend on the type of dataset. You can use it. Let's back to our project, hands-on exercise. Okay, let's uploading. So for pose, using the train, using the plank, some data, free, you can put the plank, and then go for for instance tree shape for yoga. Like 44. So already we choose two sort of data, we train them. So now close. Yes. Now already training finish. So if we using the testing something which not existed, computer doesn't know, that one, any. So this shape saying this is the plank 100%, because the model train already learned this is the point, or any other, for example this one. So this is the understand, this is the plan, or this one. Let's choose from the tree, test from the tree. So this tree, you can open the video, the webcam, try. So this one. So let's say tree, another one. Yeah, great, good job. So we already, you can play with this website, and you can learn, practice. I think good enough for us. Another website which I would like to suggest, which is the machine learning playground. You just ML playground. So here you may remember this one which I mentioned to you, decision tree. So let's do decision tree based on some hands-on practice. So decision tree is some sort of classification, is a supervised, and is a predictive. So let's skip this one, go to here. So here we need to make a data using the decision tree. So you can load your data, or you can make your data, create data. Let's create it. For example, if I make this sort of data, so remember ml-playground.com, or let's make another sort of data. For instance, you consider I don't know, some sort of the population, and the population of city, those city population, and like advanced one, here advanced one population, or for example this is the girl, this is the boy. So you can define. So maximum depth tree you can define here. So when you train your model, because decision tree, what is the purpose of decision trees? You remember, is a classification. So going to predict. So can you tell me what would be happen if I press the train? Because it's going to be classify. We don't know which class we want to class to make a decision. So should be one class like this, but one class like this. Remember, this is the discrete data, right? But let's see decision tree defining the maximum tree depths. It means this is the target. This is the, for example, girls and boys, and it can be, this is the level 1, level 2, level 3, level 4, and level 5. Can be have a depth like that. So when I consider 5, so make a one group like this, and let me clean this one. And one group like that. So if you change the 3 to 2, results same. If you change to 10, results same, because data set is very simple. Now let's go for a KNN. What is the KNN? KNN is will be classified, and based on the similar item, the result should be similar. So let's I do use the CNN. The K parameter 3. So you can read some information about the KNN here. What is the pros and cons of the KNN? So result is like this. If you change the parameter to 7, see the result change. Change to K. So some outlier data, consider this data is, for instance, this purple is the girl, this is boy. But when I put like 3, this will be considered to the girl. But when I put like 30, it will be more close to the data. And another, this is the SVM. So let's go, what is the SVM? So SVM is a classification using the, boundary, more optimal one. And better than this, specifically for very detailed. When you press the SVM, and you can understand, for example, parameters, what the meaning of the parameters, and is separation of data means classification, but maximum margin. For instance, if you put this, you will see differences. Now let's look at some neural network, deep learning or perception, also similar, layer based. This is deep learning. So I choose this one. You can read the perceptron, and based on the binary classification, the data comes and is the layer based. Very simple to implement this one. So you can play with the more, maximum can get 100. You see the result would be different. And ANN, deep learning, you will see ANN. Here you need to define the, ANN is deep learning based on the layers you defined. This is binary classification. So many layers combined together. The disadvantages is needs very powerful computation and takes long time, but its accuracy is high. So if you use the training through the ANN deep learning, then you can play with the learning rate. For instance, you increase it, you see to 1, it will be learn more. So this is now maybe because this data is very clear, right? Now if we have if this is the column, some outlier, or for example this color, some data I put here mixed with this one, not totally separated. Then see decision tree, what would be the result? Try to just boundary based on that. And the KNN, see, try to consider this is the outlier. SVM, try to see, and perceptron, cannot go for that one because it's too much simple. And deep learning is very detailed. Can you see? More layer and consideration. Let's add some data from the more complex data. Is mixed together. Machine can solve, human cannot. When you learn, after learning something, Sometimes machine works better than you. You see, the professor teach to the student. For instance, my professor teach me basic thing, and then when I teach you something, in the future you will be more professional than me. Basic, I taught you. So machine is like that. Basic, learn from the professor, from the teacher, but maybe machine better work than the human. This is the concept why we spend time for the machine, like why we spend time for the student. We teach them, but it doesn't mean a student, professor knows more than a student. But some days a student can learn, can be itself professor, even more than professor. Maybe one of my students in this class get the Nobel Prize, which I didn't. Why not? Okay, so let's decision tree. Try just look at very sharply make a classification. But Canon, see, try to cover the blue one, but the error you can see. And SVM, very professional. See, try to grab those data and bring to there. Let's perceptron. SVM works better. Neural network. Then you need to add a layer. You can add the layer and add more neuron and try to make differentiated and try to make, because I changed the learning rate, that would be better. Is more professional. So it's very useful. I think that based on learning rate, this would be very good. Then you can clear all and then try and try. Also, you can upload data in the JSON format. For instance, let's make one. For instance, if you have a data like this, okay, you can save your data. So let's put the name of this data set saved, right? And then if you have some data in JSON format, for instance, I just create my own data. Suppose this is the new data I have. So I just change to make my own data. Should be in JSON format. So data set, let's say my data set. Then you can load your data. So you can load this is my new data. So this is also possible. Okay, so we done this part. We already go through the teachable machine and ML playground already finished. So we will continue in the next section other interactive tools as a hands-on exercise.